All right, thanks everyone for coming to Building a Large-Scale Real-World Application on a Coffee Budget. I'm Troy Hunt. I'm from the Gold Coast. My house is somewhere on there, which is really nice being able to drive here, which is a really nice change. But what I want to do today is talk about a bunch of Azure stuff and a bunch of things that I've built that are real-world things. This is not sort of the hypothetical stuff. And I wanted to kind of make it pretty active, pretty interactive, and I wanted to do very little in the way of sort of pre-prepared slides and things. Who wants to see an hour of slides? All right, good. You're in the right place. So there's going to be about a few minutes of slides, and then everything else is going to be practical and hands-on. I would really like it if anyone wants to ask questions to do so and make it more interactive, because this is going to be a much more sort of fun, engaging talk than just sitting there talking to bullet points. The other thing that I'm going to do is, as I go through, I'm going to show you lots of links, lots of references to material online, things I've written. I'm going to tweet them out. So you're going to see tweets coming from @TroyHunt with all the sort of stuff that's interesting. And I'll do it real time. I'll hit a little tweet button and it will go out. So hopefully that's a lot of sort of actionable stuff that people can take away. All right, so jumping into it, who's used this site before? Who has found themselves in the Dropbox data breach? LinkedIn data breach? Ashley Madison data breach? You know, it's the only person who ever puts their hand up, it's always a guy. I don't know if you knew this, but Ashley Madison, pretty much everyone on there was either a guy or a fembot. Now, you may have seen Austin Powers and you've got no idea what a fembot is. Fembots were these sort of, almost like little tweet bot sort of things, except they weren't tweeting, they were private conversations. And they were women designed to engage men in conversation, because if you engage the men in conversation, they think that they're sort of heading in the direction they want to head, if you get my drift. And they stay there and they pay money. And what we found when people started pulling all the data apart after the Ashley Madison data breach is about 90% of the women signed up from IP address 127.0.0.1, which is really coincidental. So for those of you who have not used this site before, Have I Been Pwned is a data breach aggregation service. So what happens is when you get big data breaches like LinkedIn, like Dropbox, like Ashley Madison, the data often gets distributed around the web, all our personal info starts floating around. I aggregate the data onto this service and I make it searchable. So you can go to haveibeenpwned.com, plug in your email address, and it will tell you that you're exposed in Dropbox or somewhere like that. It won't tell you if you've been in Ashley Madison unless you use this little notify me link, and then it tells you privately via email so that your significant other or your boss or your kids or whoever can't see that you were in Ashley Madison. So I've been running this service on Azure since about 2013, late 2013 I started it. And you can see from the stats here, it's got 191 pwned websites, so websites that have had data breaches. It's got about 2.1 billion accounts in here. So accounts being an instance of someone's email address being exposed in a data breach. I myself am in 9 different data breaches now, which is 9 different accounts. So this is obviously quite a lot of data, and this is also a service that gets quite a lot of attention. So it'll be in the media and my traffic will go nuts. There'll be a big incident like Dropbox, and all these people will come to the site because they want to see, was I impacted? So I've had to deal with these challenges of this really, really high volume of traffic being directed at a site with a very, very large number of records. How do I make the whole thing fast and sustainable? And the big thing about sustainability is how can I make sure that I can keep paying for it, because I pay for this out of my own pocket. So I had to find ways of serving billions of records and sometimes millions of people a day without breaking my budget. Now, this is the whole premise of a coffee budget. And I'll define it in 3 ways, and then we'll get rid of the slides and we'll start doing stuff. So when I say coffee budget, we're going to think about this in 3 different ways. There is really kind of ordinary coffee. I do not recommend this. You know, it's like $5 for 100 gram. I don't know how long this lasts because there's no way I'd be drinking it. But let's say, for argument's sake, you get a couple of weeks out of it. This is a very, very cheap coffee budget. There are aspects of Azure and cloud which we can do here. By the way, what do we say as Aussies? Are we Azure or Azure? Azure? Good. All right, everyone else knows what I mean. All right, so there are things that we can do for $5 in Azure, and I'm going to show you some of these as we go along. Now, this to me is a very, very sort of cheap end of the scale. I would rather be somewhere up like here, about $4 to $5. So a lot of what I'm going to talk about is how can we run things at a cost of around $4 to $5 a month, or let me rephrase that, $4 to $5 a day, times how many coffees you have a day, like 2 coffees, something like that. And we're going to sort of take this coffee paradigm and apply it to actually building large-scale real-world web stuff. Now, at the other end of the coffee spectrum, we have this stuff. Anyone tried this before? So, for those of you who don't know what the gentleman here is holding, there are these things they call Asian palm civets. They're like little cats. And the little cats, they climb up the tree and they eat the coffee berries, right? Like the coffee off the tree. This comes out the other side of the palm civet. And at some point, someone looked at it and thought, this looks like it'd make a good cup of coffee. I don't know who the first person was. Anyway, they said, all right, this would be cool. And they make this into coffee called Kopi Luwak. And it's like $30 to $50 a cup. So my challenge is I've got to stay away from like the civet excrement end of coffee and get it more towards the Nescafe end of coffee. And as we go along, we'll keep looking at these paradigms. All right, so that's enough of that. Let's get rid of these slides and actually start doing some stuff. So, I'm going to talk about a bunch of different paradigms in Azure, and I want to start with the app service. And we're going to drill into the app service in a moment, but first of all, one of the things that I've found most useful with Azure is to customize your dashboard. So you can grab many of the different elements that are on the different blades of Azure and drop them all in so you've got this nice sort of real-time mission control. And you choose what's important to you. So I like to see things like, what is my current CPU and memory utilization? All right, this is important because if my CPU gets up to about there, I start scaling. And we'll talk about scale in a moment too. I like to see things like how many requests am I getting per hour? And what I've noticed the last couple of days is I'm getting this really interesting sort of sawtooth pattern here. And I think what's happening, and I've got to trawl through some logs, is I think people are hitting the API, there's a public API, and they're trying to hit it within a rate that stays within the rate limit, and it's causing things to sort of go like this. Like they'll make a few hits, back it off, make a few hits, back it off. But at the moment it's doing, what are you doing, sort of 1 to 1,500 requests a minute. I'm actually getting a lot more requests than that to the website, probably about 3 times, but you'll see why that is and why it's not showing up here a little bit later. Other things that are really important to me, and again, this is sort of about customizing your dashboard to put the important stuff on there, is I'm really interested in stuff like response times. Because I want to know if my responses are starting to really escalate what's going on. Is there some sort of long-running process that's making it all slow? That's relatively stable. There's a few peaks in there. I wouldn't mind having a look at that later on. And then the other thing that's very interesting is what are my total requests doing over time? And this is really useful because I want to see when things start escalating. So am I suddenly getting hammered by something, which could be positive press, could be a bot, you know, who knows? Important thing is I've got the stats here. So customize your dashboards, number 1. That's really cool. Okay, so let's have a little bit of a chat about pricing, because pricing is kind of interesting for the app service. So I'm going to put all this in Aussie dollars as well, so that it actually makes sense to us, which is good. Now, what I do with the app service is I've elected to use the standard app service. And you'll see we can sort of go free, self-explanatory, shared, ends up being about 10, 11 bucks a month for a site, basic, standard, premium. This to me is the sweet spot, because when you go here, you get things like I can scale out to 10 instances. So this is maximum instances. Basic's only 3. Now 3, you hit thresholds pretty quickly. The other thing you can do as standard is you get auto scale. And I'll have a look at how I configure that in a moment. So I can say, when I meet certain thresholds, add more instances automatically. This is really, really important, because one of the cool things about cloud is we can say, let's try and have enough resources to service the traffic as it stands now, and when I get more traffic, then we'll just add instances and we'll scale up. So they're very important. You can go premium. Premium starts to get very expensive. You can have a lot more instances. You can have a lot more logic apps. But for the purposes, certainly of what I'm doing with web apps, this makes a lot of sense. Now, I'm just going to tweet this out as well. So again, all these links are going to come to you guys with a little tweet button here, and we'll just keep hammering those out as we go along. All right, now, cost-wise. So this is where things get a little bit interesting. One of the things that you'll notice here is that we've got this sort of web, mobile, or API apps. And you'll see that in all of these tiers just here, it's unlimited. When you pay for a standard or a basic or a premium website, you get a logical instance of a machine. You can put as many sites as you like. So one of the first big tips about how to save money is put lots of things on the one service. So I run Have I Been Pwned off there, I run a few other little projects, I run some little helpers I use on my blog. So when I get my bill and I'm paying the amount you're about to see each month, it's not just Have I Been Pwned, it's like a dozen different websites that run off there, which is cool. Like, it's a good reuse of cost, right? Now, cost-wise, when we scroll down and we have a look at our standard service plan, first thing you'll notice is that we've got 3 different tiers. We used to call them small, medium, and large. For some reason, they're now S1, S2, and S3. They differ primarily in cores and RAM. If you use an S1 and you have 1 core, I find things start getting really limited when you're doing things like deployments. So if you're using automatic deployment from GitHub, which uses Kudu, running on the same web server that your website is running on, starts chewing up resources that 1 core has a lot of trouble processing it. .NET, and the whole site's built on ASP.NET MVC, is also very well optimized for multiple cores. So this, I was continually having performance problems with once I got past a very basic level of scale. This is great. So this is my sweet spot. Now, when we look at this cost-wise, there's 2 important things here. So number 1 is that this is 25 cents an hour. And in fact, it's kind of less than that in a way because it's billed by the minute. So I can say, I want to have, let's say for argument's sake, I want to have 10 instances for half an hour. So I'm going to pay $2, so I'm going to pay $1.25. So I can have 10 instances of this for half an hour. Now, why might I want to do that? Maybe I'm in the press and suddenly it gets a lot of traffic. Great, give me 10 instances. I'll wear $1.25. I think $1.25 is a fair trade for unexpected success. So it is billed by the minute. Now that extrapolates out to $190 a month, and that seems like more money, which it is. But when you can have these sort of very small slices of time, you can start to add and remove instances as you need to. Now, one of the best ways to do that is with autoscale. So if you jump in to your Azure instance and you go to your app service, here's Have I Been Pwned, and I would spin down here and I would go to scale out. Now, the joy of scale out, and let me ask you guys some questions as well. Who's actually using the app service? Just so I know context-wise. All right, so not many, maybe 10% of the room. App service, by the way, is platform as a service. This is not your own VM that you can remote into and install things and configure the way you want. This is effectively IIS as a service, and you put your apps into there. That makes a lot of sense because Microsoft looks after the whole thing for you, which is kind of nice. So when you have an app service, you can say, look, I would actually like to scale between 1 and 10 instances. So remember, 10 was the maximum we can do with the standard plan. If you're using this, set it all the way up. Set it to 10. Very early on when I saw this, I went, oh, I don't want to wake up and have it cost me too much money. Right? So I'm going to set it to like a maximum of 3 just in case. And I had unexpected success in the middle of the night because the rest of the world is up doing stuff. Woke up, lost traffic. And remember, those 10 instances we're looking at before, $2.50 an hour for 10 instances. So if I go to bed and the whole thing scales out to 10 and I sleep 8 hours or something like that, it's going to be like 20 bucks, something like that. I'm happy to pay 20 bucks for unexpected overnight success that actually requires 10 instances. Now you can set thresholds here. So what is going to cause it to scale? Now I want to scale based on the CPU percentage being over 80%. So if it does that, and I've got it configured to do that over a period of 5 minutes, so it looks 5-minute block, am I over 80%? Great, give me a new instance. If it does that, it can then scale back the other way once my traffic gets below 40%. This is important. You've got to get these thresholds right because if you scale too early or if you take one off too early, the thing starts yo-yoing. Like you get another instance, your CPU usage goes way down, it goes, oh, my CPU usage is down, takes one away. So autoscale is awesome. You've got to be a bit careful with that. if you want to get a sense of how far you can scale these individual instances, I've got a blog post here on scaling to 380,000 queries per minute, which is kind of cool. Now, it's important too, because it's 380,000 queries a minute of 163 million records. So this is not like I'm just loading a static file off the site. This is actually doing some big queries. So I'm going to flick that one over to you guys as well. All right, so that's scaling out. Scaling out is enormously useful. The other thing I'd really recommend, here's another sort of something that you get for free, is New Relic. Anyone use New Relic? All right, just a few. When you create an app service, you can get New Relic for free. And this is sort of the freebie edition is not going to have all the bells and whistles, the ones you pay for. But everything you see here is free. And what's really neat with New Relic is that it runs in process in the app. So it looks at exactly what the app is doing performance-wise. It also runs a little bit of JavaScript in the browser. So it can look at what's the user experience like in the browser. So, for example, the sort of stuff we see here is, here's my transaction time over the last, in this case, 24 hours. And I can see that it's a few peaks and troughs, but it's not peaking any more than, probably about 125 milliseconds. Okay with that. Here's my throughput over time. And there was an interesting thing, it's good timing. Happened last night. I was up at almost 4,000 requests a minute because there was something on Reddit. Someone put a post on Reddit, reference have I been pwned. At the same time, it was in the Norwegian news, and suddenly the traffic just started going like that. And what I find really interesting is to look at this graph and go, okay, we've got sort of a peak of 4,000 requests a minute there, and then down here we've got, geez, probably only a few hundred a minute, and compare that to my AppDex. So what the AppDex does is the AppDex looks at the user experience, and it actually runs this little bit of JavaScript in the browser, looks at how fast everything loads into the DOM and executes. And what's important to me here is that when I look at the graph of throughput, it doesn't align to the AppDex. So it's not like my AppDex gets bad as the throughput increases. So my performance overhead has remained pretty constant. And we can see that again when we look at the main chart. Everything there is pretty static. New Relic's also good because it can report on the utilization of your machines as well. Now, I never had to scale out for this traffic yesterday, and I can see that it sort of peaked at, what do we got there? About almost 60% CPU. And as you saw before, I have to get to like 80% CPU for 5 minutes to add instances. So I was able to absorb all that traffic last night. The only reason I knew that anything had even happened was I got alerts. Now, this is the other really neat thing here, is that you can go and configure it to tell you when something interesting happens. So, for example, if I jump into, on my app service blade, I'm going to go all the way down to monitoring. We've got alerts. Set these up. This is one of the best things you can do. Get alerts for things that are important to you, because they're all free, and they can do things like tell me when I have heavy CPU usage, which is the CPU time is over 3,600 seconds over a period of time. Or tell me also when there's a lot of requests coming in. So when I get more than 360,000 requests, and that last happened 15 hours ago, last night. Now when I drill down into these, we can see the thresholds. So what I've decided to do is say, look, I am particularly interested when I get more than 360,000 requests in a 2-hour period. So I don't want to know if I just get like one very, very small period of massive traffic. I want to go, look, when is it sustained? You know, like 2 hours of sustained high traffic. That's actually interesting. Now, these alerts come into play when you have incidents like this. So one of the interesting things I've learned is what sort of scales well in response to organic demand and what doesn't. Now, this bloke here, who's under my sponsor banner, has a show in the UK, and he does this money show. It's like a very consumer-facing money show. He comes on the TV and he goes, you know, here's how to save money and get your interest rates down, and here's some useful consumer tips. And his producer emailed me and said, oh, we're going to put Have I Been Pwned on the show. So, okay, that's cool. And he said, oh, we have a habit of crashing websites. And I'm like, I'm on Azure. What are you worried about? They were right. And here's like, this is the warts and all Azure, right? I don't work for Microsoft, so I can tell you the bad bits as well. And in fairness, it's not a bad thing about Azure. What actually happened is, and you'll see the charts here. It always makes sense when you see charts. I normally have somewhere in the order of probably on average a couple of hundred people on the site at any one moment. And when this thing was going to come on, I actually opened up my Google Analytics and I did the real-time thing, and it went from 200 people on the site to over 12,000 people on the site. I'm going to share this one with you. And it did it in less than 60 seconds. Because what happens is everyone got haveibeenpwned.com on their TV screen at once, like some number of millions of people in the UK. And a portion of them all went, oh, this looks interesting. And they all went to the site at once. Autoscale is cool when you have a gradual organic increase of traffic. You know, oh, my CPU is over 80% for 5 minutes. We'll give you another one. That's beautiful. But no matter what service it is, whether it's Azure or any other cloud platform that's going to scale in response to demand, if you get enough sudden traffic in enough concentrated time frame, stuff's going to break. It's just a question of how far it goes. And I'm going to talk about some of the ways to sort of stretch that as far as possible as we go through. Now, I got alerts for that very early because at least it went, hey, by the way, you've actually got a huge amount of CPU overhead. So I got alerted based on CPU because I'm only going to get alerted based on traffic if it goes for sort of 2 hours. We saw that just before. So thinking about stuff that's really worthwhile alerting you on, think about the things where you need to know about unexpected demand. You need to know about unexpected malicious activity. You need to know about scale, things that are going to cost you money. So when I look at the way I configure mine, and we look at this scale here, so I'll go back to auto scale, which was back there, scale out. Auto scale will send you emails. Okay? Email the administrator and co-administrators as soon as stuff happens. Now this is really important because I need to know that. It's costing me money. And at some point I might have to make the call, do I keep paying for all this extra scale or is something else kind of suspicious going on? I'll do the same thing with stuff like my DTUs in the SQL platform as a service. Anyone here use SQL Azure, the platform as a service one? All right, just a few. So it's kind of the same paradigm as the app service insofar as it is PaaS. You don't get your own SQL server that you can love and nurture and care for. You get logical instances of databases that sit on a logical server, but you don't have sort of fine-grained control like you would your own SQL server. Now, they measure database utilization in DTUs, or these data transfer units. And this is kind of cool in that you can see that there's a few points here, it's peaked a bit. I've configured that also for alerts. So I want to know when I'm in here on my Have I Been Pwned DB, in here in my alerts, I've gone and done exactly the same thing as I've done with my app service. I've said, hey, it's kind of important down here in monitoring, alert rules, to let me know if my DTUs get over 50%. Because now my database might be in need of scaling. 50% over 5 minutes. Now again, like the app service, if this comes on too hard, too fast, you're going to have a different set of problems. But at least the thing will tell you about it. At least you'll get the alert. All right, so that's notifications. The notifications are really important. Configure those on all of your things that are of any interest whatsoever. The other thing that's really interesting with Azure is the ability to say, I want more of something on demand. So I'll give you an example. We're here in the database. I run on a pretty cheap database. I'm going to talk about how I use the database in a moment as well. So I go down and I run, we're a pricing scale DTUs. I run on an S1 database, which is down here, which is almost as small as you can get. When I load data into the system, it actually does a lot of crunching of the data in the database. And before I do that, I'll go, you know what, I've got a bit of work to do. What I'm going to do is I'm going to go from $38 a month up to, in some cases, $1,100, maybe even $2,300 a month. But I don't care too much because I'm only paying for it by, in the case of SQL, they do it in hourly blocks, but I'm only paying for it in small increments of time. So as bad as it looks when you see $2,300 something there, you've got to break it down in these small units. So the other sort of cost-saving tip here is to scale your things on demand when you need them. And I'll give you another useful blog post here, which is one I wrote, this was a few years ago now. So I had small, sort of resource-intensive workloads, queries I wanted to do. So I had a bunch of data, simple queries, running it on my own machine, not so good. Going into Azure, and in this case I actually took the IaaS instance of a SQL service, so the infrastructure as a service where you get the whole thing. Running it on there was great because what I could do is I went down here and I said, okay, give me this guy. $2,300 a month, but more importantly, $3.14 an hour. And for $3.14 an hour, you get 8 cores and 56 gigabytes of RAM. It's not too bad. You can get bigger instances than this now as well. I'm going to take one of those. It's going to cost me, we'll put it back in coffee terms, it's going to cost me less than a latte at a coffee shop per hour to run this thing. So I can run it for a few hours, pay my 2 lattes worth of expenses, get the workload done, and then just blow the machine away. Everyone heard that saying with the cloud about treat your servers like cattle, not pets? Right? So this is the premise of don't get attached to your servers. Right? Like spin them up, shoot them, get rid of, like metaphorically shoot them, get rid of them. They're not like it used to be where you want to maintain and love and care for them. So I'll flick you that one out as well. So that's quite an interesting little way of handling that. Now I also use VMs. So I do use VMs, let's say when someone sends me data that I'm a little bit suspicious of. Right? Someone goes, hey, we stole a bunch of data out of a system. Here, open this zip file. Trust me, it's fine. Okay. Of course it is. I'll spin up a VM in Azure, load the thing into there, open it up, and so long as there's no way it's going to break out of the hypervisor or impact the remote machine which is running it, which in theory you shouldn't be able to do, otherwise we've got a different problem, and then I'll do the processing and I'll get rid of it. And I don't care if I'm paying that sort of money either, because I'm only going to be in there for a few hours. It doesn't matter. It's back to 2 coffee money. So that's really cool. I also use VMs for when I import data breaches, because I want to run some custom scripts that I've created there. I want to be able to have lower level access to an IaaS sort of level environment as opposed to PaaS. So that's really cool. Just spin stuff up when you need it. And if you're doing it a lot, PowerShell the whole thing. So you can PowerShell script all of this. And in fact, I don't have it here, but Troy Hunt PowerShell Azure. I wrote something a little while ago about just automating the entire process of spinning up all of your hosting environments with PowerShell. I'll flick you that one out too. So I was working in a large corporate environment. We were migrating a heap of websites into Azure, dozens and dozens of websites. And it was getting really repetitive, like going to the UI, new app service, this environment, yada, yada. So you can script the whole thing, which is really neat. So if you are spinning up servers, playing with them, and then just blitzing them, do the script once, run it up when you need it. It makes life much, much happier. Anyone got any questions so far? Everyone's happy. Cool. All right. Okay, so scale on demand is enormously cool. Now, if you've been reading my blog posts and watching my Twitters, you have probably seen that I use a lot of table storage. Is anyone here using table storage in Azure? So out of interest, table storage, who's using queue storage? Blobs? Files? All right, so for those of you who can't see what's behind you, it's probably about 10% of the audience using a lot of this stuff. So Azure storage is kind of cool, and this umbrella of storage covers blobs, which is just going to be files up in the storage system. It's going to cover table storage, which we'll talk about at the moment, which is what I'm using for a lot of Have I Been Pwned. Queues, which are very basic message queues, and a file storage. So you can actually use it like you would a file system. And these storage constructs are enormously efficient at doing certain things. They're bad at doing other things. And this is where things kind of get interesting. This is what I really like about the options that we have today. You know how, and maybe your companies are still like this, but you know how very often you'll have this discussion with the manager or the architect or whoever it is, and they'll go, we're going to build a website, we're going to need a SQL database. Because this is what you do, right? Like if you build an application, you've got to have a SQL database. This is just the done thing. No one ever gets fired for having a SQL database. Now, this is the way we always thought of things, but now we've got a lot more options available in terms of how we actually store our things. And we have SQL databases, and they do some things well. And we have these storage constructs I was just talking about. So what I thought I'd do is let me tell you how I use both of them, because I sort of go towards this very promiscuous, for want of a better word, application of using relational databases for SQL Azure and using storage. So let's put it in context first in terms of money. So we'll go here and look at SQL database pricing. Now SQL is a big thing, right? Like SQL is a very large relational database system. It does RDBMS things very, very well. It can be very expensive. So I'll give you an example. I'm in here, we'll skip straight over to single databases, and we'll have a look at what we're paying here. So I'm using standard databases. Basic gives you more limitations. So Basic, you can only scale up to 5 DTUs, gets a bit limited. Different retention periods in terms of backups and things like that. Like Basic is probably not what you want to be using if you're doing anything serious. I'm down here, you would have seen before I'm using an S1. Now an S1 gives you 20 of these DTUs, these data transfer units. And I know that 20 is usually fine, because when I go back and look at my dashboard, and I close that blade, I reckon I'm doing okay with 20. Very, very rarely hit the threshold of 20, which is good, because 20 is quite cheap. 20 is 2.6 cents per hour. So if we start to sort of extrapolate these out, and we look at the calculator and we go, okay, it's 0.0257 per hour, so it's going to be that much per day, 31, is that about 19 bucks? Did I do that right? It's normally about 30. Ah, S1 versus S0. Now, okay, so here's a good observation. Different scales cost different amounts of money. But you'll notice that they're all pretty linear as well. So an S1 is basically double what the S0 is. And then an S2, you double again, right? So everything kind of goes in this nice logical flow. So if we were to multiply that 19 out, we're back at about 38 bucks. So 38 bucks a month, putting it back in coffee terms, one Kopi Luwak, or back in my my normal sort of latte drinking mode, so what are we at there? Sort of 6, 7, 8, you know, it's not too bad. So I'm getting a relational database here that's managed by Microsoft, so I don't have to do all the manual stuff. There's all the automated backups and things, which it does fantastically. They manage it for me. Now that's really good, but what I notice is as soon as I do anything such as loading a large data breach, these DTUs go all the way up to 100% and they stick there, right, until I'm finished. So I often have to scale it up manually beforehand. The other thing that happens is in my SQL database, I don't have a whole lot of data. Reason being is because you've probably seen this before. Anyone ever built a database and it works fine when you're developing it. And then you get more and more and more data and you're going, gee, it's starting to slow down, right? Like as you scale larger and larger and larger, you need to have more scale of the database engine. Now this is what brings me to the interesting bits here. Oh, by the way, this is the DTUs, for those of you that are interested. So a nice sort of definition of how many DTUs you get at different scale. And if you really want to spend 16 grand a month, you get a pretty good database, but it's 16 grand a month. So good little DTU definition there. Now this is the interesting one. This is what I like. This is table storage. So when we start looking at storage in general, and again, storage combines queue storage and table storage and blobs and file storage. What I'm really interested in here is the way this table storage model works. Now, table storage is pretty much just a key value pair. You've got a concept of a storage account. You can have multiple tables within a storage account. A table can have multiple partitions, and then each partition has multiple rows. And I'll tell you how I set that up in just a moment. Main thing is have a look at the cost. So for the first terabyte worth of data, and Have I Been Pwned's got about 200 gigabytes worth of data in it. For locally redundant storage, so you have multiple redundant copies in the one data center, you're paying that much per gigabyte. So we'll put that back in my sort of terms. So if we say it's 0.0892 per gigabyte, and then it's 200 gigabytes, we're up at nearly 18 bucks a month. So it's about $18 a month for me to have a couple of hundred gigabytes worth of data sitting in table storage. But there's more. You've then got to pay for transactions. Because down here, Microsoft says, we're going to charge you 0.46 cents per 100,000 transactions. So you're paying both a storage capacity price and a utilization price. So how much am I using? This was an exceptionally busy day yesterday because of the press the service got. And in that exceptionally busy day, if I scroll that down a little bit, I had 2.68 million requests. You can see how much lower it is now that that crazy busy period sort of has backed off. But let's be generous. Let's say, okay, we're going to work with 2.68 million a day. So if we have 2.6, and then there's going to be a lot of zeros, 2.6 million per day, and then we're going to pay per 100,000 transactions, so we'll divide it by 100,000 like that, and then we're going to pay this much in dollars, so it's 0.0046. All right, it's going to cost me that much a day, so 12 cents a day. So have a think about it, and in fact, we'll put that back in month terms as well. We'll work that out by 31. So we're going to take sort of what was about $18 before, $18 to store the 200 gigabytes, and then we're going to pay just under $4, which is less than about the cheapest cafe latte I can get these days, at a coffee shop. So we're paying 20 and a little bit dollars a month to have 200 gigabytes worth of data being accessed 2.6 million times a day. Now this is why I use table storage, because it is super, super, super cheap. But here's the other cool thing. It's not just cheap, it is blisteringly fast. I've got a little test over here, and I'm going to tweet this link out here, and I don't think I have a page title on this, so I'll say, how fast is Azure table storage? Like so. Now I loaded this one before. You can see that you can pass an email address in here, and it took 38 milliseconds. So what I'm doing here is I just got a little stopwatch just sitting on the part of the process that goes to table storage, pulls back a record. 38 milliseconds. Let's give that another hit. 6 milliseconds. Oh, that was good. I like the way that's going. 5 milliseconds. And then you go, oh, okay, it must be optimizing the query. So what we'll do is we'll just pick another alias. Something random like that. It's still pretty good. Now, what I do here, and the reason why this is so fast, is I said you can have a storage account, multiple tables. Every table has partitions. Every partition has rows. So what I do is, with my partitioning, I go, okay, let's take the domain, and that is going to be a partition. I've only got one table. There's one table with the 2.1 billion records in it. So I've got one table, and then I've got millions of partitions because there's millions of domains. The gmail.com one and the outlook.com one are massive because there's a lot of email addresses. So when I do a search for this, I can go straight to the foo.com partition, and then my row key is the alias. So I'm searching specifically for the exact row in the exact partition based on this. And this is what makes it so fast. And even if we go and change the partition, okay, like that. Oh, that was a bit slow, 84 milliseconds, wow. But yeah, put this in context, we're going, oh, 84 there you go, that one's better. 84 milliseconds. That was a bit slow to search 200 gigabytes of data with 2.1 billion records and pay 20-something dollars a month for. Now, that is why I do this. I have a promiscuous approach to my data storage. So I have the table storage doing this, and I have the relational database doing the things that the relational database does well. So for example, if you go to the site and, where were we? New tab. If you go to the site and you sign up for notifications, you can go up here, go notify me, you plug in your email address, and then you go, I'm not a robot, and you click the button here. It will go and create a record in the relational database. The reason why is because when I load data, so let's say someone gets hacked tomorrow, 100 million records. The 100 million records will get put into SQL as a staging environment, and SQL does joins really well. So fantastic. I'll put that data into SQL, I'll do the things that SQL does really well, I'll scale it up for a little while I do it, and then I'll scale it back down. If you tried to do something like take my table storage and query based on anything other than the partition and row key, it's pretty terrible. It's really bad because you're using it in a way it's not designed to work. So you've got to sort of go, all right, what are the strengths of each one of these storage constructs? And then you mesh them together, right? You create this nice hybrid of things that together work really well. Now, I've got a link in here as well, working with 154 million records, about how I did this. So I'm going to flick that out to you guys as well, and you can have a look at that one. All right, so that is kind of cool, and that makes things very, very easy. Now, while I take a drink, any questions about table storage? It's awesome, right? Okay, I do also use queue storage quite a bit in there as well, and I won't delve into that today, but in some of these links I've just tweeted out, they've got references to how I use queues. They're very, very good for doing things like, for example, every time I send an email, rather than waiting and the web app sitting there trying to create an SMTP connection to my mail provider, just drops it in a queue, and then I have web jobs, which are free with your website, that sit there and they get triggered by the queue. So they go, there's a new email, picks it up in the background, rather than having to wait to make the SMTP connection while someone's sitting on the web page. All right, let's go on to something a little bit different. Security. Apparently, security is important. Agree? This is what they tell me. Now, there are multiple ways of getting your security things for free today, which is really good news. Good example. Let's Encrypt. Has anyone used Let's Encrypt before? All right, only a couple. So, I'm going to tweet you the link so you can go and read this one in all its glory later on. But while that is going out, for those of you that have not seen Let's Encrypt before, Let's Encrypt is many good things. Free is a very good thing. Automated, also very good. So it can do the process of requesting the certificate and then renewing the certificate in an automated fashion. It is backed by some organizations who we would consider quite trustworthy, such as EFF, Mozilla, Akamai, Cisco. What Let's Encrypt is trying to do is sort of unseat the incumbent CA model, where you've got the likes of Komodo, the world's largest CA, that used to go, give us 70 or 80 bucks a year and we'll give you a certificate. And only people who could afford security would get it. And what Let's Encrypt are doing now is just saying, well, no, like everyone should have security. It's a good thing. So you can get certificates for free from them. The link I just tweeted out tells you how to set it up in Azure. In that link, in fact, I'll give you a bit of a sense of it. As we get down towards the end, you'll see how much is involved in setting it up in Azure. Keeps going. It's not particularly good. It's good for free stuff that is not too critical. And I really want to support Let's Encrypt. I like the way they're going, but it's not kind of a first-class citizen in Azure yet. I have been asking Microsoft, I've designed it, I know exactly how it will work. I'd like them to do this. Put a button there. And you go and you press the button, and then you just get like security magically out of the box. So hopefully at some time we'll see this in Azure. It's not there at the moment. Frankly, I would rather actually go and pay Microsoft to get a certificate that's about 70 or 80 bucks a year and not take the chance of something in that great big long blog post going wrong. If you've got personal sites and that sort of thing, and if your certificate wasn't renewed or you had a problem, not such a big deal. Have a read of the blog post though, because it's kind of interesting. Try something a bit different. Who has used Cloudflare before? Right, so the correct answer is all of you have used it, whether you know it or not. Less than 10%, I'd say that was probably 5%, have, I assume, used it insofar as you've created stuff on it. So we're actually going to set something brand new up in Cloudflare now, because I want to show you the mechanics of it, and that leads into some of the other things I'm showing you. The reason why I said you've all used Cloudflare is they put trillions of requests a month through their infrastructure. Either them or Facebook, it's a bit of a race, are the biggest properties on the web. More requests than any other single organization. Because there are thousands and thousands of sites around the world that sit behind Cloudflare. Now the reason I'm showing you this page here is this is the crypto page on Cloudflare for Have I Been Pwned. Cloudflare gives you SSL, and we really should say TLS. SSL is the old thing that we superseded with TLS, except we keep saying SSL because if ever you want to do stuff like actually require a secure connection in .NET, you've got to say require SSL. So it's kind of stuck in our vernacular now. They will give you SSL for free, among many other really good things. Now, I want to show you how easy this is because it's cool, and we'll just go and do the whole free thing. I realized the other day that I still have this site, and I did this a few years ago. This is a very self-ingratiating title, I know, but it is a really, really good demo, and it's free, and it's been viewed hundreds of thousands of times. I did this a couple of years ago when it was a little bit earlier days in Azure. Got a lot of press, people really liked it. You'll see down a little bit further on the page, there's a video in here. I'll tweet this out because you're gonna want to watch this when you go home. Which is just sort of, this is the value proposition of Azure and why we want cloud and what all this sort of scale stuff is. Anyway, I was looking at this the other day and I was going, I'm going all over the place talking to people going, you should put HTTPS on all your things. And then I realized I don't have it. Here's an interesting tangential trivia thing. When you look at my site over here, how do you know it's secure? Because it says so, it's got a big secure. When you look at this site over here, how do you know it's not secure? Because it doesn't say so. All right, and this is this kind of paradox at the moment. Like our default position on the web is insecure. And the only time we know it's secure is when it tells us it's secure. If it doesn't tell us it's secure, then we make the assumption it's not secure, even though it doesn't say not secure. Unless you're Qantas, for those who've seen my tweets today. It's a different story. We won't go into that right now. All right, so let's make this secure. And here's what I'm going to do. I'm going to copy this domain here. I'm going to jump back to Cloudflare, and I'm going to add a site. Now, I sort of want to go through this and show you how easy it is because I love what Cloudflare does in terms of giving you TLS for free, and then we're going to look at other things that it does for free that make you spend even less money on Azure. So what you do is you go there, you enter your domain name like this. Okay, just the domain, which is great, and we go begin scan. And what it's doing now is it's just going and looking at your DNS records. So you can plug any website you like into there. I've not done anything to verify that I own the site. You'll see how that happens in just a moment. It's going to go away, it's going to look at my A records, my C names, my TXT entries, any MX records. It looks at everything that's in DNS. And it's going to come back in a moment and it's going to say, this is what we reckon your DNS records should be. And we're going to look at it and we're all going to agree it's great because we don't have time to argue. But it should come back and say it's happy. Now you can do this with any website, and what's going to happen is it'll come back and say, here's your records, is this okay? We'll go yes, and then it will go, okay, we're going to give you some new name servers. Scan complete. Continue setup. And we go there, and it goes here, and we all agree this is correct, didn't we? Yes, good. One other thing to point out here. You'll see we've got this little cloud here. And what we've got here is the A record, which is here, and the C name is going to be routed through Cloudflare. Okay, the other C name here, which is this AW verify, which is just sort of the verification entry that you have to make when you first bind a domain in Azure, is not going to route through. We're going to continue that. And it says, okay, cool. Could you please give us some money now for a business website or a pro website? I've got some other accounts with them. I think they're being really generous and putting $0 there. It's normally $200 a month. This is where you actually want to read the instructions and don't accept the defaults because we don't want $200 a month. We want $3 a month. And when we take $3 a month and we continue, it's going to come back and say, hey, you've got to change your name servers. And you'll see here that at the moment, here's my 4 name servers. They're all on DN Simple, that's my registrar. And they're going, get rid of that one, and then use these 2. So let's do that. So I'm going to get that one from there, and then I'm going to go over to DN Simple, which is my DNS provider of choice. And I'm already on World's Greatest Azure Demo. I'm going to change my name servers like so, and then I'm going to go, there's that one, and then we'll go back to there, and then I'll get this one from there, and then we'll go over here, and we'll put that one there. Whoa, that didn't look good. We'll take out that one, change name servers, and that's it. So what's going to happen now is DNS magic will take a while to do its thing, because DNS is like that. Okay, all very good. Thank you. Wait, change take effect. DNS magic will happen, and then we'll go and check it in a moment. Sometimes it happens really quickly, depending on all the magic of the internet. All of our traffic is going to start to route through Cloudflare. Now, one of the interesting things with Cloudflare is that they have rather a lot of servers. So they've got this global network that looks like this, 102 data centers. And what it means is that when we make a request for worldsgreatestazure.demo.com, we're going to go to the closest data center that we can find. And it's going to hit that data center. That data center is going to service up our HTTPS, our SSL TLS certificate, and we're going to have a secure connection to there. We can also make it secure from there all the way back to the Origin website. The blog that I'm going to tweet in a moment explains all that. Now, by doing that, we get other performance advantages as well, but let's just check first. We'll see, maybe it's routed through there already. One of the ways you can tell is that if you jump into your dev tools, go to network, Cloudflare adds some custom headers, which I'm not seeing yet. When it works, we should just be able to do this, HTTPS. If that's going to Azure, it won't work because I don't have a valid certificate on Azure. All right, so it's not there yet. What we would have just gotten here is we would have gotten star.azurewebsites.net. All right, so we all know what DNS is like. It could take a few minutes, could take a few hours. Check this later on, and you'll see that it's now through Cloudflare. So that's one of the really important lessons here. You can get your HTTPS for free within minutes. This is really cool. I run my blog through this. I run every site I possibly can through this because I get the HTTPS things for free, which is really good. Let's go on, though, because we can do a lot more than that. So by having those 102 edge nodes around the world, they can start to do things like caching. So let me show you what I mean by this. Remember before I said, look, we can see the traffic on the Azure portal here, and we go over here and we can sort of see, 1,500 a second or something. And I said it's actually a lot more than that. I'll show you why. Because if I go back to Cloudflare, and I go up here, and I go to Have I Been Pwned, and I go to my analytics, and this is going to be my analytics for the last 1 month, I've had 95 million requests go to Have I Been Pwned. I reckon it's quite a lot for a site I run on a coffee budget. I think that's okay. 72 million have been cached. Now this is really cool because that is a huge amount of traffic that's not hitting my Azures. And if it's not hitting my Azures, then I don't need as much scale in order to run it. And it tells you how much that actually saves you. So if we jump down here, it's actually said, hey, I've needed 76% less fewer servers. Now, it's a bit of a contrived number insofar as it said, we have taken 76% of the requests off your origin and we've served them from one of those 102 locations around the world. But when I look at things like I mentioned that British bloke before on the TV and said, I was there, it popped up on the TV and I got flooded, the site got flooded. This got me a lot further than what I would have gotten otherwise. Because only about 24% of the traffic actually hit my site. So I scaled 4 times further for the same cost than what I would have otherwise. I didn't used to have Cloudflare on this. I put it in probably about 4 or 5 months ago when someone was trying to DDoS me, which is not a lot of fun, by the way, in case you haven't done it before. And after I put it on, I saw these costs skyrocket down. So I used to be scaling out almost every other day. Now, even yesterday when I had that really big traffic, 4,000 requests a minute, no scale. It's also saved me quite a bit of bandwidth. So 80% of my bandwidth got taken off the Origin server because all the images and things like that. Have a think about all the stuff that's on here. If I go to particularly a page like this, there's a lot of stuff there. There's 191 images because there's one for each data breach. I rarely ever pay for that data from Azure. Now, mind you, data is cheap from Azure. This is saving me in the order of $2 a day. But when I'm doing this coffee budget thing, that's probably 15 lattes a month, right? It actually works out quite a bit. No, it's not that much. What do we get? A couple of dollars a day, $20, perhaps 4 lattes. But I get into this minutiae thing. It's almost like a game, right? Like how cheap can I make Azure? It's good fun. I highly recommend it. So it's taking a huge amount off the Origin. There are other things, though, that are really good about this because not only does it take the traffic off your Origin website so that you don't pay for it and that you've got more scale from the existing resources, but because it's serving it from their CDN in those 102 locations, your users are getting much faster responses. So I've hosted this up in the West US data center because I thought, this is a secret, I thought I'll put it really close to Microsoft so they look at it and think it's really cool because it'll be so fast because it's close to them. Not so good for us because we're on the other side of the world to everything. So when you get it from Cloudflare, you're getting it from somewhere close. So another thing it does, which Azure can't do yet, which makes it really cool. If I go back to my network tab here and I hard refresh this page, I have turned on the protocol column, and there is a lot of H2. And H2 is HTTP2. You can't serve HTTP2 from Azure yet. We just got it in the latest generation of IIS as part of Server 2016. It's not served up from Azure yet, but you can get HTTP2 if you're using Cloudflare. And just in case people don't know how significant HTTP2 is, anyone seen this site before? I'll tweet this while it's loading. This is good fun. What this is doing is it's loading a whole bunch of images over, how do we know it's not secure? Because it doesn't tell us it's secure, over HTTP. And then it goes, oh, it took 12.5 seconds. And then you go, oh, I wonder how fast it goes if it's secure. And you go, oh, wow, I thought security was meant to be slow. Because this uses HTTP2. And when you have HTTP2, you can have this sort of file stream of content. You can get a whole bunch of requests into this one file stream. It goes super fast. So by wrapping Cloudflare around your thing, you actually get that performance advantage. Now, this is sort of part of the theme of one of the ways you can save money is get other people to pay for your things. I know, it's a crazy thought. But Cloudflare will do that. So they'll give you that for free. One of the other things I learned really early on running this service is that I don't need to pay for public JavaScript libraries. So I've got jQuery, I've got Bootstrap, I've got Font Awesome, and I went, you know what I should do? I should actually go and get those off Cloudflare. Now, mind you, Microsoft has got a CDN for public libraries, Google's got a CDN. I don't really care where you get it from. But the cool thing is that when we go down and have a look, let's go right down the bottom here. You will see, all right, CDN.js, Cloudflare, yada, yada. Which is good. So my public libraries, regardless of whether I want to route all my traffic through Cloudflare or not, my public libraries come from here. Is anyone concerned about this? So have a think about what could happen, all right? Like if you get your JavaScript from an external site, what happens if someone changes the JavaScript? There was an incident a few months ago. I don't know if you saw this. Trump was in the news. We couldn't avoid a Trump thing. Someone on his team did something stupid. I know, it's crazy, crazy thought. But in all seriousness, it was on the news. And what was on the news was that they found that Trump's website was doing this, but directly pulling it off a GitHub repository. Now, what do you think you'd do, hypothetically? What do you think you'd do if you could make a pull request to that repository, change the script? Because you could run arbitrary JavaScript in his website, and let's just use your imagination from there. So, now, this was a good point, right? And this is really the same sort of problem. Not as bad, because making a pull request to GitHub is probably a lot more likely than someone screwing with public jQuery libraries on Cloudflare. But we've still got the issue, right? So how do we solve this problem? Because you want to be able to do this. Because if you do this, you don't pay for the traffic. You're going to serve content to people that are much closer to you. And the other cool thing is that because these public CDNs are so popular, and because something like jQuery is so popular, when someone comes to my site, they might have already gotten this library from somewhere else. I'm going to give you a demo because there's a really good security construct you can use that helps justify doing this. So I'll give you an example. Urban Dictionary. Now, by pure coincidence, every time I've done this demo over recent weeks, there has been a constant theme. I don't know why, but anyway. So here's the reason I'm showing this. If we jump into the source here and we do a find for Cloudflare, we see this, right? And this is really the same concern. These guys are saying, let's have a script tag here, let's go to cloudflare.com and let's load that JavaScript. And what we're going to do is we're going to just fire up a bit of Fiddler. Who uses Fiddler? Most people. Who's used Fiddler script? See, less people. Fiddler script is cool, right? What you can do with Fiddler script is we can go up here, and it's a free add-on for Fiddler. You might have it installed already. And we can say, hey, let's go to on before response. And what happens is this event allows you to actually change the response before it comes to the browser. So it's going through Fiddler, which is a local proxy on your machine. We're going to change that JavaScript file, and we're going to sort of emulate what would happen if that JavaScript file changed on the source. And what I'm going to do, I've got this little Trumpification script here. So we're going to emulate what would have happened if his website had had content changed by virtue of someone making a pull request on GitHub. All right, so we're now routing through here. What I'm going to do is we're going to look at Urban Dictionary. We're going to load up this script just here. I'm going to jump to the end of it. That's still in cache. Let me give it a hard refresh. Because if I give it a hard refresh, the request is going to go back through Fiddler, and it's going to get Trumpified. Okay? Now it's been Trumpified. So what would happen if that script actually loaded up in the browser? Because this is emulating the problem, right? This is emulating the fact that someone might actually change that script upstream and cause the website to do things that we wouldn't normally expect. Right. And this demonstrates, and in all honesty, like if you were going to hack Trump or anyone else, you probably wouldn't do this. What you'd do is you'd put like a Model logon for Facebook or something, because you can write JavaScript on the page. So you can pop up a little Facebook login page and go, hey, show your support by leaving your Facebook username and password. Many people will do it. So what we're showing here is that we've been able to modify this site by changing that upstream file. Let's try this over here on this site, because we just showed how I'm pulling in some jQuery. Let's go home, and in fact, we'll go and make sure that I'm not doing any tricks here. Open up the JavaScript file. That JavaScript file is already cached. We don't have Trumpification script. Let's go and actually reload that, like so. We'll give it a hard refresh so the request goes through Fiddler, comes back to here. There's my Trumpification script. So we've now modified this script. Will I get a modified website when that script is loaded? You're shaking your head because you know it would be a crap demo if it did. It wouldn't go real well. All right, it's not going to modify the site. I'm still pulling it off an external location. But what we're going to see here instead is that if I go into the console, we're going to have a bunch of errors about many unrelated things, which is kind of curious. I wonder why that's doing that. I may still have other scripts in there. No, I don't. Let's give it another hard refresh. So what it's going to do is, where's my SRI? Content security policy. So I've been playing a lot with content security policies lately. And I think what's happened here, it's just got the old one. Oh, here we go. No. Otherwise, I'm just going to jump straight to the punchline. Let's just try one different page. We might go to, say, let's go to the domain search page. Pop that open. All right, I'll tell you what. Let's explain what would happen anyway. In my source code down here, my script tag looks a little bit different to other script tags, and I'll show you why. I've got this little integrity attribute. Has anyone ever used this on a script tag? All right, 1, maybe 2. Couldn't quite see. 3. So not a lot. Integrity puts a SHA-384 hash of the script file. So what you're doing is you're saying, hey, let's take this script file, this jQuery.min.js. So what you do is you take one version of the jQuery file which you trust, which you know to be good. Maybe it's the one that you would normally serve from your own site. And you create a SHA hash of it. Okay, you can do a SHA-356 hash. You can also do the SHA-384 hash. If you don't know how to create the hash, you go over here to the SRI hash generator, which I'll share just there. Now, the other thing is I'm going to kill my fiddler, because that makes things a bit funny. Oh, where's my connections gone? Let's try. So what I'll do is I'll just copy, where was it? Have I been paying source code? Let me give you an example of how it works if the connection's still there, otherwise we're going to go to backup. So we go back to there, we would paste in the URL of the script file, we'd go, please go and create me a hash of it. Oh, there we go, we saw a connection. And there's your whole script tag. So have a think about the mechanics of what's happening here. When you put this on your website, And you have to get one good hash of the script, right? It's no good getting a maliciously modified script and having that hash. So you get one good hash of your script, you put that on your website, and then what's going to happen is your website will download that jQuery file, and it'll go, oh, hey, you've got an integrity attribute here. Let's now create a hash of that file and compare it to the hash just here. Now, what you'd normally see on the website is that if they don't match, you get an error in your console. And it says, hey, there's been an integrity mismatch. We're not going to run the script. It downloads it, but it won't run it. So if you try and maliciously modify that file external to the site, it won't execute it. What then happens on Have I Been Pwned, when it all works as expected, is the file still works, or rather the jQuery still works, because I've also got a fallback position. So I'm looking to evaluate window.jQuery, and if I can't evaluate that, it'll go, hey, just pull it off my local file. So now we're sort of back to serving it locally. So you get the best of both worlds, right? Like you get to get it for free from someone else and they pay for it, and you get the integrity attribute, which is if someone else changes it, it'll still run. Yes? Oh, good question. How have I compromised the HTTPS access to the JavaScript? So you're saying, how did I manage to modify that traffic as it loaded? All right, cool. So for folks who've used Fiddler, some of you might have done this before. What you do in Fiddler is you go Tools, Telerik Fiddler Options, Connection, HTTPS rather, and you tick this box. And what happens is when you tick this box, you get a little window that pops up that says big scary text ahead. It literally says big scary text ahead. And what it says is we're going to install Fiddler's root certificate on your machine. And what it means is by doing that, Fiddler can sit in the middle, it can intercept the request, it can make requests backwards and forwards to the origin web server, re-sign the traffic with its own certificate, and your browser will trust it. So when you do that, I'll show you what actually happens in the browser. We'll go back to here. I'm going to give this page a hard reload. And what we're going to see is we're going to see Fiddler's certificate. Okay? Because it's re-signed the traffic in the fly. Now, if I turn Fiddler off, so we go back to there, we kill that, and now it's not being routed through Fiddler, and I give it another reload, that'll come up, the page will load, let's try it again, page will load, security, view certificate, and now we're back to the correct certificate. So it's literally man in the middle. Yes? All right, good question. So are you at risk of the origin server being compromised by Fiddler? So there's a couple of things here. When I do this, and I do this a lot in my workshops because we use Fiddler to intercept a lot of traffic, one of the things that people are really worried about in that respect is they go, if I trust Fiddler's root certificate, what if someone else gets in the middle of my traffic and they serve up the Fiddler certificate? Will I trust it? Every Fiddler certificate is uniquely signed, so you're only trusting the traffic from your own local instance of Fiddler. You can't then take that certificate, serve it up from the origin, and make it work against other people. Your certificate will only work against your machine. All right, so that one is kind of neat, like being able to use SRI and have other people pay to serve up your content. So I want to sort of jump to some questions in a moment because we've got about 6-ish minutes left. So the big things there are looking at using platform as a service and just scaling out for what you need. So using things like autoscale, getting notifications when it happens, trying to find the right use of how much table storage versus relational database storage can I use. Use them harmoniously. They work really well together. So doing that, playing to their strengths. Also doing things like getting your certificates for free. You can get Let's Encrypt for free. You can get Cloudflare for free. Let's check, actually. We'll see if it's actually working now. That makes an enormous difference. In fact, we might even just jump into Firefox and see if it has managed to get a brand new connection. Firefox. So also using the likes of Cloudflare, and they're not the only one, there are other providers doing similar things. Let's see if we get HTTPS. No, okay, so DNS still hasn't done its thing, but you know how that works. So also using this to serve content from cache and then using things like the CDN to make other people not only pay for the traffic, but to get it to you much faster, using faster protocols, and possibly even just getting it from cache because you're serving it up from a public CDN. They've probably seen it before. All right, so I want to sort of leave a little bit of time for questions about anything related to this or other similar things. Yes? Very good question. So what he's asking is he's saying, you're getting the SSL, by which you meant the TLS, from the browser to Cloudflare, but then what's happening from Cloudflare to the origin? Because for all you know, you could have an unencrypted connection. And this is part of the the paradox that is HTTPS. So let's maybe take Have I Been Pwned? When we see HTTPS, a lot of people go, well, HTTPS means it's encrypted all the way to the server. It's never meant that. It's always meant that it is encrypted to some point of SSL TLS termination. Very often it's load balancers in front of the server. Might be in the same data center, so all right, minimal risk. Doesn't necessarily mean it's going to the server. There are multiple ways that you can configure Cloudflare to do that relaying of the connection. So for example, in Have I Been Pwned, if I go into my crypto, I'm using full strict. Now what full strict means is that you get HTTPS from you to Cloudflare. Cloudflare is going to decrypt your traffic, which it kind of needs to do in order to cache stuff and serve stuff from cache. Then it's going to relay the traffic back to the origin website, also over HTTPS. And it's going to validate that my website serves up a valid certificate. Now, by the way, that certificate you can get for free. Cloudflare have this Origin CA implementation, where you scroll down a little bit and you go, hey, give me a certificate, and it goes, here you go. You load that into Azure. So what you're getting here is you're getting Cloudflare encrypting and decrypting the traffic, but everything else encrypted. Now, there are other ways to do this, though. We can sort of ask the same question. When you look at my blog and you go, it's secure, again, this doesn't mean that it's being encrypted all the way back to the origin. It means it's being encrypted to some point of HTTPS termination. And when I look at my blog, rather than using full strict like Have I Been Pwned, I'm only using full. Now, here's the nuance. I run my blog on Ghost Pro, which is a really good blogging platform too, by the way. So Ghost is the blogging platform. Pro is their managed service. So it sits over there in Amsterdam, runs on their Ghost Pro infrastructure. They do not have a facility for me to load a certificate onto their platform. So I can't go and get a certificate for troyhunt.com and load it into Ghost Pro. They can return a certificate from their server, but it's not the right one. It's a wildcard ghost.io certificate. So what full does is it says, we're going to communicate from Cloudflare to the origin server over HTTPS, but we're not going to validate the certificate. That protects against passive eavesdropping. So if you're sitting on the wire and you're looking at the traffic, you can't see what's in it. It doesn't protect against active eavesdropping. So if you're sitting on the wire and you inject your own self-signed certificate, which is not valid, Cloudflare will still trust it because we're on full. We can't validate the certificate anyway. We're not getting the right one in the first place. Now, many people look at this and they go, well, that's kind of crap. You don't have end-to-end encryption. You know, it's useless. Chuck it out. And I've written a blog post on this. I called it Unhealthy Security Absolutism. Because people are going, if you can't get encryption all the way to the origin, it's no good. But have a think about this, right? So think about where are the risks for a man-in-the-middle attack. Anyone ever connected to dodgy Wi-Fi? Not just mine, I mean in general. Okay. Or you go somewhere like this, and hopefully everyone here is trustworthy, but you don't know if the conference center is intercepting your Wi-Fi. Maybe we don't trust the ISP upstream of them. All of that you've got full encryption from. And then somewhere upstream of the ISP, they connect to Cloudflare. Cloudflare goes out over the internet backbone. That internet backbone traffic could be intercepted, could be modified. And the sort of actor you've got to worry about then is NSA, state-sponsored attackers. They're the ones who have access to internet backbones. Internet backbone providers as well. For troyhunt.com, I'm not too worried about the NSA being able to see who's reading my blog posts. I don't think that's a big problem. If you are building a bank, it's a different issue. So there's a sort of a commensurate level of security that you can apply here based on what your origin site can do. All right, folks, my timer is saying I've got about 20 seconds left, which is probably about perfect timing. So with that, I need to leave you with the slide that says go and win a Spark After Dark drone, which kind of sounds pretty cool. And if anyone has any questions or other things or want to reach out to me later on, you can find me at Troy Hunt. And thank you very much for coming to my session.